Hi, in this video, we're going to look at the options for dynamic IPv6 address allocation. Okay, so in IPv4, we basically have one option, DHCP, and that's stateful DHCP. So meaning that the DHCPv4 server is going to allocate addresses, assign addresses to clients, and maintain state of who has received what address from the server. And here's kind of the overall, it's a broadcast discover from the client. The server sends a unicast offer. The client sends a broadcast request saying, I will would like to have that address. And the server says, it's all yours. Okay, so IPv6, it all begins with the ICMPv6 router advertisement message. So ICMPv6 is described in RFC 4443, those wonderful RFCs. All the information is right there. That's the great thing, the cool thing about all this stuff. Anyway, it's a lot more robust than ICMP for IPv4. It's more than just messaging, but what I like to say how IPv6 conducts business and includes neighbor discovery protocol. Okay, so ICMPv6 neighbor discovery actually has 5 messages: router solicitation and router advertisement messages, which is for router to device messaging. And that's really has to do about IPv6 addressing information and some other information like what link or what network you belong to, who's your default gateway, and things like that. Also, neighbor solicitation and neighbor advertisement messages. We'll look at this later when we look at ICMPv6, neighbor discovery messages, but that's equivalent to ARP and IPv4 and use also with duplicate address detection. It's any device to any device messaging. And there's also a redirect message similar to redirect messages in ICMPv4. Okay, so I mentioned it all begins with the router advertisement message. The RA message suggests to IPv6 devices how it should receive its IPv6 addressing information automatically. The RA message is sent periodically every 200 seconds or whenever it receives a router solicitation message from the host. Okay, so the thing with in IPv6 is that a stateful DHCPv6 server, or even a stateless one, may not even be needed. Everything may be contained in the RA message. So a router advertisement message, it is sent by an IPv6 router, which means a Cisco router must be configured with the IPv6 unicast routing command. That will make the router allow the router to forward IPv6 packets, and also enables it to send out router advertisement messages on its LAN interfaces. Okay, all right, and just know you can still configure IPv6 addresses on a router without this command, but it then becomes pretty much like an end device for IPv6 and not a router for IPv6. Okay, so there's 3 options the router advertisement provides. The first one is SLAAC Only, and this is the default on Cisco routers, meaning I'm everything you need. You don't need to talk to anybody else to get about any kind of addressing information. Again, this is all suggestions to the end device operating systems. Option 2 is I'm pretty much everything you need for what you need to create your address, who your default gateway address is, etc. But you may want to talk to a stateless DHCPv6 server for things I won't provide. And stateless meaning the server will give you things maybe like the address of a DNS server, the same information it would provide to everybody. Third option is, look, use me as your default gateway. Matter of fact, the DHCPv6 server will not give you that information. So use me as your default gateway address. But for everything else, you can go talk to a stateful DHCPv6 server. This is similar to DHCP for IPv4. So options number 1 and 2, that the DHCPv6 servers, there's nobody maintaining state of an address. And option 3, the stateful DHCPv6 server would assign the address and maintain state of who was assigned what address. Okay, so in method 1, stateless address auto configuration, we'll take a look more of that in chapter 9 when we look at SLAAC. Okay. And chapter 10, we'll look at SLAAC and DHCPv6. And in chapter 11, we'll look at stateful DHCPv6. So we're going to look at all of these in much more detail. Okay. Chapter 11 also includes DHCPv6 prefix discovery. This is actually really cool. So for example, at my home, I use Comcast, and they don't provide me just an single IPv6 address. They actually provide me with a prefix, a network address. From that network address, which is a globally routable address, it's not a private address, it's globally routable, I can have up to 18 quintillion devices on my network, all with global unicast addresses, globally routable addresses. Okay, so client configuration. What's interesting on Windows, it says obtain an IPv6 address automatically. Okay, just similar to what it would say for IPv4. What's interesting on my Mac is in IPv4, it says, whoops, I was hoping I zoomed in on this. It says using DHCP, that's IPv4. On IPv6, because it's not necessarily DHCP, it just says automatically. Okay. And yeah, you can actually see the addresses that I use on DHCPv6. Okay. All right. So if a device say connects to the network or boots up, and it has not received a router advertisement message, it will actually send out a router solicitation message requesting the router advertisement message. Okay, that will be either sourced from its link local address or unsolicited address, meaning all zeros, because as you're going to see here in a moment, the router advertisement message is going to be sent out to everybody on the link. The router solicitation message is sent to the multicast address, all IPv6 routers. The router will send out its router advertisement message from its link local address and send it to all IPv6 devices, even if it was received from a router, if it's sending the router advertisement message out because it received a router solicitation message. Now there's some variations. You can actually change this destination IPv6 address. So when it does receive a router solicitation message, this could actually be changed so it's a unicast directly to this device. The reason why you might want to do that is for wireless devices. So on a wireless LAN, so that all the devices aren't having to wake up and process router advertisements unnecessarily. The only device that needs to receive this, in this case, would be the wireless device that sent out the router solicitation message. Okay, so router advertisement flags, there's 3 of them, depending on the method. So let's take a look at these. The address, so by default, the A flag is set, we'll look at each one of these. A flag is set to on and the O and M flags are off. The address auto configuration flag, which is the default, suggests to devices to create its own global unicast address automatically, to do it itself. And we talk about in the next chapter, next set of videos, how it does this. The other configuration flag, when that's set, that means that the device, this should be used in the other configuration flag. This should be used, here it is here, should be used with the A flag, because it still needs to create its addressing information automatically, but it means that there's other information, like maybe the address of a DNS server, to get from a stateless DHCPv6 server. Again, we're going to take a look at all three of these in upcoming videos. The managed address configuration flag, when this is set to 1, then the O flag is ignored. And it basically suggesting to the device to ask a stateful DHCPv6 server to get its address, just like in IPv4. Now, what's important, we'll take a look at this in more detail in a later chapter, but if you don't want it to also create an address using SLAAC, you'll need to turn the A flag off. So we'll learn how to do all of this in upcoming videos. Okay, so the address auto configuration flag has a default setting of 1. If you want to set it to 0, and we'll see why you'd want to use, I mentioned it already, when you have stateful DHCPv6. We'll see how to use that later, but this would be the command to set the A flag to 0, either for specific prefix or for all the prefixes that it advertises. But the no auto config means do set the A flag to 0. The O flag, we'll look at this later. This can be set to 1 using this command here, letting the device know that there's additional information besides what it creates using SLAAC. There's additional stateless information from a stateless DHCPv6 server. And the M flag is set by using this command. You notice that these are all per interface. The ND stands for not Notre Dame, but neighbor discovery. I almost forgot myself. IPv6 neighbor discovery. Okay, so we have the auto config, which is set, it means set it to 0, but these are how you'd actually turn it on. And the no option is how you reverse that. So how you reverse these, but we'll talk more about these in later videos. Okay, so SLAAC only. Here's an example, sends out the router solicitation message. The router sends back a router advertisement message, which this is SLAAC only. A flag set to 1, the O and M flags are set to 0 or off. The device will then use the information, the RA message, to create its own addressing information, and won't consult any kind of stateless DHCP server or stateful for any other information. Okay. Method 2, this is where the RA message sets the A flag to 1 and the O flag. So in this case, the PC will use the information, the RA message, to create its own global unicast address and other information like the default gateway, but it will also get additional information from a stateless DHCPv6 server, like the address of the DNS server. Stateful DHCPv6, the RA message has the M flag set to 1, and in most cases, the A flag should be set to 0. The O flag should be also, although it's ignored. In this case, the host will only use the IPv6 address of the RA message. So it does use the RA message to get its default gateway address. For everything else, it's going to go talk to a stateful DHCPv6 server, which will give the end device everything it needs, except a default gateway address. But we'll give it a global unicast address, prefix length, of course, DNS address, things like that. Similar to IPv4, except no default gateway address. Okay, so if you wanted to learn more about the actual messages that is sent and received between the client and a DHCP, the router advertisement, and even the DHCP server. Very similar to those in IPv4, but I go into detail in the book. So in Table 8.2 and in that Chapter 8, this is all discussed in more detail. There's also a relay agent. We'll talk more about this a little later, but this is where the DHCP server may be on another network. So we'll talk more about that a little later. Okay, something to be to think about or to know about is something known as the DHCP unique identifier. So this is a little different with IPv6. We'll talk more about this when we talk about DHCP in a later chapter. But the DUID is every DHCPv6 participant has one DUID that uniquely identifies the entire device. Okay, but it also has something known as an identity association. So a client will have at least one identity association for each interface using the services of the DHCPv6 server. Yeah. So I've got a little, here we go. So an identity association is a collection of addresses assigned to the client. The IAID is that each one of these interface cards will have its own IAAD, identify association identifier, identity association identifier. Yeah. And the whole collection of these is referred to as an identity association. But this is how, we'll see this later with DHCPv6. This is how a DHCPv6 server, a stateful server, knows which device, or when it assigns an IPv6 address, allocates an IPv6 address to a device, how does it maintain who got that address? And it does that by these IA identity associations, which are part of the DUID. So each device has a DUID, and then one or more of these identity associations. And it says, okay, I've assigned this IPv6 address specifically to this device. It's how it tracks who got what address. In IPv4, that's done using a MAC address. In IPv6, they use these DUIDs and IAs. Okay, but more on that when we get into DHCPv6. All right, so that's a little overview of dynamic IPv6 address allocation. More in the upcoming videos on SLAAC and stateless DHCPv6 and stateful DHCPv6.